Comparing means of paired data, part 2. We were talking about new homes that often come with energy guarantees. That is, the builder guarantees the cost of heating and cooling the house will be below a certain point. When there is a complaint, the builder will estimate the insulating power of the house by taking temperature measures inside and outside the house at randomly selected locations, such as inside and outside a particular window, which makes it paired. And we're going to use a 95% confidence interval to estimate the average difference in temperature inside and outside the house. So we'll do the regular 5 steps, but we're going to use D-bar since it's paired. So let's go ahead and go to our calculator. In list 1, I put the inside temperatures, and in list 2, I put the paired outside temperatures. So this would be maybe outside and inside the same window, outside and inside the front door, etc. And we want to find the difference. So we're going to go second, list 1 minus list 2. Notice that my cursor is up here at the title. And these are the differences between the inside and outside values. And then we need to find D-bar, which is the average of these differences. So you could go to stat, calculate one variable stats for list 3. And it turns out the average of the differences is 20.7. So it does appear that there's a difference between inside and outside the house. If there wasn't, that average would be 0. We will then use a t-interval, but we will talk about that in 1 second. Before we run the t-interval, let's go back to our 4 steps and make sure we know what we're doing. We are trying to estimate the true mean difference in temperature between inside and outside the house, which in this case is D-bar. Okay, and it appears to be 20.7 degrees Fahrenheit, but that is probably incorrect due to randomization variability. I will create a 95% confidence interval for the true difference of the means. So we're going to test our conditions. The first condition was that the locations were randomly chosen. And then the next condition is that the number of locations need to be greater than 30, but they aren't. There were only 7. So we're going to do an NPP. And if you do an NPP and you do it on list 3, you'd get a picture something like this. Notice that we kind of have one outlier. The rest of it's fairly linear. So we're going to say the NPP is approximately linear with one outlier. Maybe that's a spot with poor insulation, so the difference is way skewed from the rest of them. But anyway, we will continue with caution, because for the most part it's linear. Now we need to find the confidence interval. Now I would do this with a calculator, but you could do it by hand. So we'd find a 95% confidence interval, and that is the average plus or minus the margin of error, which is t times the standard deviation, and the standard deviation for that is found by the standard deviation of d divided by the square root of the number of differences. So we get 20.7 plus or minus t times 4.04 divided by the square root of 7. Again, you can get this 4.04 from the one variable stats, but all of this, honestly, I'm going to get out of the t-interval when I do that. And then again, inverse t would come from 0.975. Remember, you have to add the tail. So even though it's a 95% confidence interval, this is 0.975. And the degrees of freedom, which would be the 6, and tells us what our t curve looks like, is n minus 1. Or in this case, the number of differences minus 1. Or 7 minus 1. Anyway, we are going to get a confidence interval between 16.96 to 24.44. Now let's look at that on the calculator. We're going to go to t-interval because we don't know the actual population standard deviation, and we're talking about means. Hit enter. We have our data of differences in list 3. We want a 95% confidence interval, and it does all the work for you. There is our confidence interval, and I just happened to round mine a little bit. Shows us that the difference was 20.7, so you didn't even need to do one variable stats. And there's our standard deviation of 4.04. And now we can conclude what we know about the confidence interval. So I'm going to say I am 95% confident that 16.96 to 24.44 captures the true mean difference between inside and outside the house. And what does that do to let me say if there is a difference between the two? Or in this case, maybe, I guess in this case, maybe that the insulation is working. And I would say that it is, because if it's not working, inside and outside the house would have similar temperatures. But here we're fairly certain, or 95% confident, that if we kept doing this, we did sample over sample over sample 95% of the time, we capture the true mean difference, and it's going to be a positive number in between these two values. So it looks like the insulation is working a little bit.